Hi all. Okay, so I have prepared all the cells that I want to build for the 12-volt battery for this box. This is a part 2 of this video, and again the most important thing in this stage is to make sure that all the cells are more or less on the same voltage, and show you examples. 3.64, 3.61, they are all between 3.6 and 3.7, which is great because you don't want one cell to be charged and the other one to be discharged, because if you are connecting them together it is like doing a short. So you need to make sure that all the cells, before you start this process, in the same voltage, more or less. Again, if the change is 0.1 volt or 100 millivolt, this is a little lower, this cell, but it is still okay. And we'll continue to make sure that all of them are okay. 366, 366. Okay, as you can see, more or less all the same voltage. This allows me to connect all of them in parallel. And for example, if one cell is 3.5 volt and the other is 4 volt, this is not a good case because it's too high difference between the voltage. At the end, if they have the same resistance, internal resistance, so if you're doing it, it will end probably at 3.75 volt. But anyway, you are doing a short and you don't want to do it. Okay, as you can see, last two cells, all of them are great. More or less same voltage, all of them tested. I've checked all the internal resistance, which is between 18 milliohm to 22 or 23. This is again a great number. By the way, you see this have a different color because I had a short when removing the nickel from the top when taking it apart. So I decided to put another case so it will be fully isolated. Because, by the way, I see I have another cell now. You see this dot here, so it's not recommended to leave it like this. So I will put heat shrink also to this one, and then we'll continue. So now everything is good. By the way, I got this fishing paper that you need to put on the positive in order to isolate when doing the metal strip connection welding. But in this case, I have already on these cells. You see it come from in the original cell, so I don't need additional one because it's already here. So I can leave this for now. Now we will go and look at our BMS in order to make sure how to put the connection. So you see positive, negative, and negative to positive, negative to positive. And here we have a battery minus and battery plus, and here the BMS connection. And also on the other side we have the charging port. I'm not sure that I need it, and we need to check after connecting everything if it can be charged from the regular terminal of the positive and negative. Sometimes yes, sometimes no. Anyway, it came with a charger and a cable, this cable. So I'm not sure I will use it, but we'll see. And now for the parts that we need to do. So if I'm looking here, so I know that I want, if I'm starting, let's say this is like this, so all the positive will go here. So I can already put the cells inside after I've verified that everything is good. I'm just putting the cell before the welding, so it will be ready for the last process. So all the row is in the same direction. And then the next row is of course opposite, so all the positive will be this way. You see, it's like playing with a Lego if you know how to do it correctly, so no need to worry. Cells are discharged, almost discharged, not fully discharged but almost. So even if I have a short, nothing will explode at this stage, because we are working in a safe procedure. Okay, and then the last will be of course again the other side, and then, by the way, all the cells are from 9-bot scooter. I remove them and check them, and they are okay. So you see it is stuck pretty. You need to apply some force to get it to the position. So they done it pretty good. Now we are already ready, and we need to put of course the other side as well. So this is all should be before doing the welding. So it's a little, need to use some force. A lot of force. Okay. I'm using a lot of force in order to make sure that everything is okay. Okay, so we can do last check. All positive are same direction, and then all negative, and then all positive. We're okay. Here I see there is a little space, so it's not yet fully. Whoa, this is a lot of force. Okay, I think we're okay. Make sure on your space that you're working, no metals, no things that can do any short, although they're fully discharged. It's a lot of cells in parallel, so it's a lot of power eventually. Okay, so we will start doing the weld. What we need is of course all this to connect here, and then one strip here, and on the other side it will be not this, of course not too short, but this too. Okay, so you want to make sure that you are doing everything very carefully, and all the time looking if you have spark or something, or things that are not as you think, so you need to stop. Okay, for this purpose I will use the K-weld. K-weld is a professional welder, and then we do all the welding. Okay, so the battery is ready to weld, and what I'm doing here is adjust to 30 joule. I think this is enough, and now I'm going over all the connection and doing the welding itself. Nothing special about the welding. By the way, I put the magnet to catch the nickel in its place when starting. And just doing it from all the cells. This is just the welding process, nothing special. Okay, and I'm working with a power supply that is charging a capacitor. These capacitors, yeah, are super capacitors in order to make be able to work with the K-weld. And yeah, I will put the current for lower current right now because it's okay. And now I'm just continuing the process, making sure that on each cells I have at least 4 points. And this is the process, and we'll continue and see how it is when it is ready. Okay, so after completing all the welding process, you can see here and here, I put the BMS on this side. And now it's time to close everything. But before closing everything, by the way, these wires are soldered and not with welding. But before doing it, I will apply some Kapton, just in case of some problem with the main wire, that it will not short anything. If it's too hot or something happens. Something like this. And I also, by the way, had to cut one side of the plastic here because I think that it will not close properly if it is not done. So I will also put Kapton here. Just to make sure that everything is isolated, and even if something inside the battery loose, there will not be any short. You can put also heat shrink if you would like. Now, hopefully, it will close properly. But before doing it, I will do another thing, just to make sure that the best, by the way, is to put silicone on this connection. Maybe I will put silicone because it is better than putting hot glue that can melt. Okay, so I have some silicone. We'll put some here on the positive, some on the negative. Now I can close everything. Yeah, it can close somehow. And that's it. Now I have a battery that hopefully is built well and will not explode. I remind you that the voltage was, by the way, the P plus and the P minus are going directly here. You can check the voltage. Yeah, we have a voltage, so we are okay. Yeah, and now I can try to charge this battery to see if I have current that is going okay. Okay, so yeah, now I will put the charger and I will see that I have current that is flowing inside. So I will put 12.6 volt, 1 amp, just to check that everything is okay. So I'm putting Yeah, and we have a charge and everything is okay. We done just a quick, just to make sure that no short and nothing is a problem here. And yeah, I can show you that I'm not bluffing. It is charging now. I can show you this by using this current meter, of course. So you can see that we have 1 amp of charge. So this battery is charging properly. And we're all done. By the way, this battery is much bigger than this size of regular 12 volt battery. Usually there are 9 amp hour, 7 amp hour. This one have 7 cells in row that each is 2.5. So hope you enjoy. That's all. Thank you and bye.